Good morning all. Today we are going to discuss types of spectroscopic methods of analysis. So spectroscopic methods are based on the measurement of the electromagnetic radiation emitted or absorbed by the solute or sample. So there are two methods for the determination of absorbance of the solution. First is colorimetry and second is spectrophotometry. So colorimetry is dealing with only the visible region. That wavelength range is 400 to 800 nanometers. But in the case of spectrophotometry, it is going to deal with the UV as well as visible as well as IR spectrophotometry. So in case of colorimetry, we are not going to get accurate results, but spectrophotometry gives us accurate results. So next is the instrumentation of spectrophotometry. So it is having 6 components. First is source, second is monochromator, third is sample cell, fourth is detector, fifth is amplifier, sixth is recorder. So you can see the diagram that source, then monochromator, then sample cell, detector, amplifier, recorder. So the role of the source is to provide radiation of sufficient intensity. So source provides radiation in polychromatic direction or multiple directions. Then second component is monochromator. So monochromator functions as or it converts polychromatic light into monochromatic light. Third is sample cell, or we can call it as sample holder, or we can say it as cuvette. So cuvette holds the sample. It doesn't absorb radiation. Next is detector. So detector detects how much light is absorbed and how much light is transmitted. So detector converts electromagnetic radiation into electrical signals. Amplifier. Amplifier amplifies the electrical current if required, and recorder display the result, that is absorbance or concentration. So we will see the components again. So source of radiation, if you are working in UV region, that is from 190 to 350 nanometer, then you are going to use deuterium lamp. And if you want to work in visible region, you are going to use tungsten lamp. That is the range is 330 nanometer to the 780 nanometer. Next is monochromator. So the role of the monochromator is to convert polychromatic light into monochromatic light, as earlier I stated. Then there are two types of monochromator, that is quartz prism, that is you are going to use in UV region. So this is quartz prism, and second is the glass prism. This one is the glass prism that you are going to use in visible region. Next is the sample holder. So there are three types of sample holder. First is plastic, glass, and quartz cuvette. So quartz cuvette is transparent in the full range 200 to 700 nanometer. Plastic and glass are only suitable for visible spectra. So you can see this is glass and this is quartz. So quartz can be used for both regions, UV as well as visible. But in case of plastic and glass, you are going to use this only for visible region. And this is called as cuvette. Next is detector. So detector converts electromagnetic radiation into electron flow, current or voltage. So examples of the detector is phototube, photomultiplier tube and photoelectric tube. So you can see this is the example of phototube that transmitted light from the sample. That means I'm talking about this, that light is passing from monochromator to the sample, and that light is going to be fall on the detector. So you can see this, that light is coming from the sample and it is falling on the cathode, that is cylindrical cathode. Then it is going to be on the anode, then again cathode, anode, cathode, anode. In that way, that light energy is going to convert into electron loop. So this is called as detector. Next is amplifier. That amplifier amplifies the current if required. And last is the recorder, that is going to display the reading on the screen. So that is about the instrumentation of UV visible spectrophotometer. This is single beam spectrophotometer. So in the practical, you are going to see the colorimeter, and two solutions you are going to see, that is copper sulfate. If you are using copper sulfate, then you will find the lambda max, that is 620 nanometer. And if you are using ferrous sulfate, you will get the lambda max 530 nanometers. So what is lambda max? So lambda max, it is the wavelength which shows maximum absorbance. So this you are going to see in the practicals. But again, I am saying that spectrophotometer is more accurate than colorimeter, because if you are going to take a little bit turbid solution, colorimeter is showing zero reading, but same solution is going to say show something, that is 0.01 or 0.02, like that on the spectrophotometer. Next, application of UV visible spectrophotometry. So first is quantitative analysis. So qualitative analysis. So qualitative analysis means what? If you are going to get the concentration, or depending upon the lambda max, you are going to say this is the compound. So qualitative means you are going to say the name of the compound. That is called as qualitative analysis. So see, the UV visible spectra of an unknown organic compound is compared with the spectra of various known compounds for identification of that compound. For example, benzene is showing lambda max 230 nanometers. If you are getting lambda max 230 nanometers, then you can say the given compound is benzene. That is called as qualitative analysis. Second is quantitative analysis. That is, you are going to find out concentration of unknown solution based on the Beer's law. That is called as quantity. Next is chemical kinetics. So as absorbance is directly proportional to the concentration of reactant or product, with the progress of the reaction, the change in the extent of absorption per minute can help to study the kinetics of the chemical reaction. That means you are going to find out whether that product is formed or not formed, whether reactant is there or product is there. That you are going to find out by using UV visible spectrophotometer. Fourth is structural information, that is lambda max is a characteristic value of different chromophore and chromophore oxochrome. The structural parts in the organic molecule spectrum gives structural information of the unknown compound. So cis isomer is showing different lambda max and trans isomer is showing different lambda max value. Or you can see in the next, that is, if benzene is there, you can see 225 nanometer is the value, and if oxochrome is attached, and that is CH3 is attached to the benzene, then that value is changed to 269 nanometer. If OH is attached, then it is going to show 270 nanometers. So you can say if 270 nanometer is given, then you can say that molecule is phenol. If 269 nanometer is given, then you can say that molecule is toluene. And if 225 nanometer is given, then that molecule is benzene. That is called as structural information. By using next, by using UV visual spectrophotometry, you are going to determine dissociation constant of weak acid or weak base, Also, you can determine or detect the impurities present in the given compound by UV visible spectrophotometry. Thank you.